Alright, so I'm really into movement and how to produce like movement, especially in 3D print. So I'm going to walk you through one of my workflows to create something interesting like a ball joint within Blender. And I think it'll show students like, what kind of things are required in order to learn to produce something that moves in 3D print land. Okay? So I'm always going to use the Maya preferences for this because I just am accustomed to Maya, and I really like Blender, so I like both programs. That's just how I kind of roll with things. Under here with the user preferences, I go down here to take inverted zoom direction off and just make sure these are both Maya. Okay, another thing I always do is get out of perspective mode. 5 on the number pad for that, and X to delete geometry. Alright, so I'm going to add a mesh and a UV sphere, and I'm going to take this UV sphere, and you notice it's 32 by 16. What I'm going to do is up the segment count here to like something like 48 and 24. If you use the top number to be the bottom number to be 1/2 the top number, it turns out to be nice uniform polys. So just a tip. Alright, and on the keyboard allows you to bring up this menu, and this is the bread and butter with measuring within Blender. So the first thing I need to do is think about this needs to be at least 30 millimeters. So we'll go 30 millimeters. Okay, now I'll jump into my front. Now you can switch between front, left, or front, right, and top by just hitting 1, 3, and 7 on the number pad. Okay, another thing that's very useful is this is your outliner. So here's a sphere. Okay, this is this sphere. Shift D will allow you to copy that sphere, and right clicking allows you to kind of like get out of the operation. So now I have sphere 1 and sphere 2. Just for tutorial reasons, I'll go in here to the little box and click on, this is my outer and this is my inner sphere. Okay, Z on the number pad, or Z on the keyboard, allows you to switch over to wireframe. My inner sphere, I need to be at least 5 millimeters less than that. So in 3D print land, I don't like to have an internal wall any thinner than 2.5 millimeters. Okay, so in this case, I want to go 5 millimeters because it's a ball joint and it suffers a lot of damage over time, because the friction in the inside. So 25 millimeters would be that. Okay. Now, I'll take this inner sphere, and what I'm going to do is copy it. Shift D. Right click to out that, and I'm going to label this one 0, 1 inner. Anytime I use a 0, 1, that just means to me in my head Boolean operations. So here's another little tip. This sphere is 25 millimeters. I have a 0.5 print head. Now, I have found that what happens is you take that number and you use that as your variance between Boolean cuts. In other words, there's a 0.5 variance between everything in the world. If two pieces need to move without any kind of friction whatsoever, or just a little bit of friction, mind you, because there's little bumps and nodules, 0.5 would be what I use. If I have a 0.35 on my print head, I'm going to use 0.35. It works every time perfectly. So this one 0, 1 inner. If I'm going to use it for Boolean cutting, I need this to be 25.5. Okay, so that's 0.5 bigger than my inner sphere. Baking your noodle, I know I am. Okay, so you'll see in a second. So here's my outer. I'm going to go over to the wrench, Boolean, difference, and choose 0, 1 inner, and apply it. So now look at the sphere, the inner sphere. I'll hide this one, choose inner. If you get real close here, you'll see there is a 0.5 variance between the inner and the outer wall of the outer sphere. That will allow this to freely rotate on the inside. There might be a little sanding depending on if you have like your layer height set real thick. Alright, moving right along. So now we need a peg in order to rotate. So I'll add a mesh cylinder, E to rotate. Then I go up here and I immediately type in an even amount, like 90 degrees rotation. I need this dimension to be like, let's say 10 millimeters. Just coming up with some numbers here. And I find 10 millimeters to be a very sturdy part. Also, think about drill bit sizes as you're doing this. So if I have a 10 millimeter drill, I can like clear out a hole in case there's junk in there. Also think about drill bit sizes, so and a 0.5 variance. So if you want 10 millimeters drill bit, you're going to have to use 10.5. Some more noodle bacon. Okay, so that's going to be a 10 millimeter drill bit in real world because of the 0.5 variance. Okay, tab on the keyboard allows you to go into component mode, and I'm just moving these vertices. I just selected them like that, and I moved them out. Doesn't matter how long. Okay, so now I need a slot in order for this to rotate in. Well, so I have this. This is my peg. Shift D to duplicate it. This is my 0, 1 peg. And in order for that peg to freely rotate within this slot, I need what? 0.5 variance. So 11. Cool. Tab on the keyboard allows me to go in here and choose 1/2 of this and move it up. Oh wait, it would be faster if I did it this way, so let's back that, Control Z. So I'm going to take this and Shift D to duplicate it, rotate it back to 0, make sure my other rotations are all 0. Okay, this needs to go into half of the sphere, just like the other one. Just like that. Now I'll hit Tab, grab the vertices, and move it out. Okay, so let's kind of look at what this looks like. I'll move these up to 1/2 of that. Let's hit Z on the keyboard. Now you'll see that this is a slot where that peg can rest, and this is going to be a slot where that peg can rest, and together I just hold Shift and join them together. So now I have 0, 1 peg. And I'm going to use 0, 1 peg as a Boolean cut for the outer. So just choose outer, choose Boolean, choose difference, and choose 0, 1 peg. And apply that. Now I can hide that just like the other one. And now you'll see that I have a peg with a sphere that I can join these two together. And that will freely move within this sphere. In order to be useful, I would have to add one more cylinder to the mix. And that one's going to be, again, 10. And again, I would have to think about drill bit sizes. And if you're in America, which I am, but I still use metric system because it's smart. I said it. That's right. Burn me at the stake. Metric system rocks. So here we go. But if you're in America, you would just convert your 11/16 drill bit to a decimal point and then use it like that. But then you would also have to convert it over to millimeters because this is in millimeters. The whole program is. Well, it's within metric units. So I've grown fond of metric units because I've been modeling in metric units for quite some time. Grab the outer shell, inner shell, or outer shell, peg, and join those together. Alright, now this is awesome, but we need to print it. How would we print something like this? Well, I'm going to break this into 2 videos. This was just the production of it, and now I want to show you the workflow to get it out into 3D print land. So see me in the next video.